All right. Good afternoon. Thank you guys for staying. I know there's probably food outside and everybody's ready to go, but thanks for hanging out. Oh man, look what we got on the front row here. Alex and Paul, all right. I am Larry Patterson. I am from Gulfstream Aerospace. Gulfstream is one of General Dynamics' companies. I have been with Gulfstream for about 20 years, and about 15 years ago, I started the Supercomputing Center for Gulfstream, and so I'm the founder and still the director of it, and I've taken on over the last 5 years, taking on more visualization stuff coming out of the CATIA world, now keeping it 3D and doing a lot of augmented and virtual reality. So I get to play in all of the R&D type areas. So let's talk a little bit about my parent company because it allows us to do the things that we do. The aerospace side of General Dynamics is about $8.5 billion. It is one of the largest, if not the largest, usually every year. Marine Systems is always about the same. And we, of course, you're probably familiar in some of the labs with the information technology side, GDIT and GD Mission Systems. But Gulfstream, along with Jet Aviation, make up the larger aerospace division.
Is it coming through? Course for aviation, connecting the world like never before, empowering people, expanding horizons. We advance and define the finest experience of flight to this day and into the future. Gulfstream is boundless. Our integrity endless. Our ideas, limitless. Our commitment, timeless. Through authentic passion that expands possibilities. Visionary craftsmanship that enhances experience. Inspired performance that connects continents. And unparalleled support that ensures success. In an ever-changing, ever-connected world, we are defying the limits of possibility, approaching the speed of sound.
Right here, there's this quiet spike. We'll talk about that.
And on this mission, Gulfstream is boundless.
All right. So you saw there, it said the approaching the speed of sound. So if you look at all of our competitors, we do build business jets, and a few competitors like Bombardier in Canada and Falcon on the French side. But we have stretched toward the top of that. We go after all of the longest, largest, fastest. We go after all those superlatives. Gulfstream today, about 18,000 employees. You see the jets that we have are the 280. And then the next one is the 500 and 600. Those are both brand new aircraft that we were using DDN storage for the 500 and 600. The 550's been around since about 2003 when it won the Collier Award that year for the best thing that happened in aircraft and aerospace. The 650, when we came out with the 650, it was at the top of the game. Everything was flying around 0.80 Mach or 0.85. We fly at either 8.5 or 9.0. So we are very close to the speed of sound now. Of course, the FAA still has guidelines that will not allow business aircraft to fly over the U.S. without being greater than Mach 1 because of the sound barrier and those problems. So obviously, that's one of the things you saw the quiet spike on the other picture is the long nose that trails, starts larger, and as it goes out, gets smaller. So we're trying to dissipate that signal as it comes back. So, of course, part of the math that we're trying to solve on the supercomputing is figuring out how that we do that so that we can fly across Alex's house and not break his windows, when we go down there. So let's see. So you see right up there on the 650, and let's look at the next one, the 650. You see that the smaller end of the line is the 280. So as companies are starting to make in the hundreds of millions, getting up closer to the half and more, a lot of companies use the 280 as the transport. So all you sales guys, beef it up and get Alex and Paul into one of those. Let's see, the 550. The 550 has been around a very long time. It's still one of our special mission aircraft. The 500 and 600 were both clean sheet aircraft. We designed those fully over the last decade, and they just entered service. The 500 just entered service, going to the customers, and the 600 is coming very soon. The 650 was the one that back in 2013 we launched and won another Collier Award for that one for the greatest thing that happened in aerospace because it opened up the skies. You can fly it up to 0.925. It can almost go between any 2 points because we broke the barrier that most companies could not get through, 7,000 nautical miles. And then when we came out with the extended range Gulfstream, it flies 7,500 nautical miles. So our brethren up in Canada, they have now thrown the gauntlet down, and their next one coming out is supposed to go around 77, 78. So we now, as of 3 weeks ago, we threw the gauntlet back down and challenged again, and you see the G700, so we're going for at least 7,500 nautical miles, and the G700 is longer, larger, it is bigger, faster, better. Let's put them all in there. Supercomputing. Why did I do what I did? I came out of, as you saw, nuclear engineering and then electrical engineering, and then I went into Gulfstream, and the senior VP there said, I need you to go sit in the IT seat, and I need you to work on the technologies that will make us better. So I reluctantly went across the field, and now it's been a great decision because the last 15 years we've built things like you're looking at the picture there. That is the G650 window, which is the largest window on any business aircraft. And now on this new 700 that we launched, it has 10 of them on each side. So you smarter guys than me tell me how we're cutting those larger holes in the sides of this aircraft, and this thing still flies and still stays together. But the thing that I'm most proud of, you look out at that winglet. If you guys remember, a lot of the CRJs and a lot of the commuters started throwing winglets on those aircraft because, well, we'll get into a little bit of how planes work, but that is the design you'll see on the G700 that just came out, and it's one of the sexiest things out there. So I needed them to dumb it down since I was only a nuclear and electrical engineer. I needed these aero guys to kind of teach me. So Paul, I'm going to show you today. This is how an airplane flies. They said, Larry, thrust good, lift good, weight and drag bad. I'm like, okay, I can do this. So I actually taught my daughter now how a plane flies. But I handed it back to all the engineers, and then they come in with this. All the double E's and the flight control guys, they threw Cray and HP supercomputers in the plane, bunch of engines, and then you had no room for people. The weights guys, they built everything out of paper or I guess just a quilt or something. The structures guys, they've got iron. All around. They've nailed everything to everything, welded everything to everything, and bolted it all together, so I don't think that one's going to fly. The manufacturing guys, they've always got plywood laying around, so they cut a few sheets in half and nailed it all together. That one's got, you can put one person in it. The aero guys, they forgot to get people in it, so they just built you two big wings and said, well, I guess we need an engine. Propulsion guys, they put about 93 engines, I think, on it. The noise guys, that thing is so small, it's so thin, it cuts through the wind, you can't see anything. But the problem with this one couldn't be our new G700 because none of them will work for us. So then I said, okay, bring it up a notch, guys. And they said, all right, the top one, we're going to talk about polys and triangles and NURBS, and no, we're not. So we start looking, I can look at the pretty pictures, and I see down on the bottom, has this thing got a... So got a, yeah. We see down here, blue is good because we got the quiet spike going on, and as we put those points on, I can still remember that they said blue good, red bad, lift good, drag bad. I'm getting this arrow thing. Then they bring me back in there, and some dudes named Navier and Stokes, and they start doing second order differentials, and I'm like, oh, what you really want me to do is go build this big calculator. Yeah, let's drop some of this in there. So they drop the math in the supercomputers that we build, backed up by your storage. And I understand again. I pushed about 47 buttons. Wrong button. That one. See there? There's no blue. There's no red under this. It's all blue right here. So maybe at the front end of that aircraft with the quiet spike on, this computational fluid dynamics that we're figuring out says maybe all of those sound waves aren't going to perpetrate to the ground. So as we're looking in one of our studies, General Dynamics has always talked about, we're always looking at supersonic flight, and we would love, like everyone else, Ariane and others, we would love to get supersonic flight back in the air, but we are a little different than everybody else. They're going to go and play out over the water and go really fast there, but then they have to fly slower than us over land. We're trying to solve the science. So as you know, the calculator has to get bigger and bigger to solve those kind of science problems, and I'm not like you boys in the labs that have unlimited resources. So we build these little baby computers. Again, oh wait, where did it go? There, that one. This one. Come on, Larry. That one. So red, bad. You look at that wing. We talked about that winglet. They can throw that blended winglet on there where they get a smaller vortex off of the wingtip. So you start really looking on our aircraft. You look at the upcoming G650, and you're trying to figure out how and why do we do those. We spend an awful lot of time on CFD. My supercomputing world is about 90% CFD on all the multiple programs. And we spend a lot of time on the wing. Why is the wing bowed? Do we know why that thing bows? Why does this thing, in the earlier aircraft, you would have the winglet that would just be at exactly 90 degrees, and then now it lays back. Well, not only does it lay open, it also leans back, and you saw the curve on it. Now we're throwing curves in them. Why? Because we get better and better at sizing the wing, doing the leading edge so that it gets as much lift as you possibly can. And then we have larger and larger wingspans as we can do the larger aircraft so that we can have more fuel so that we can fly farther, because we want fastest, farthest, best on all the superlatives. So that 650 was the first aircraft where we ran, and I'm not allowed, Gulfstream still won't let me give numbers and all of that, and so I'll talk as much as I can, but tens of millions of CPU hours to design the new 650 after we were running the 450 and 550. You keep going down the line, and the world said it's the best ride on the planet, and you see fly the farthest, fastest speeds. That is our goal. You want to go as far as you can and as fast as you can, because the people that are using these are presidents of countries. They're all of our presidents of companies and a lot of military. So we want to get them there as fast as you can and get them as far as we can. I wanted one time in my life to outdress Alex and Paul. So I brought pictures to show that one time I did it. They invited about 40 of us up in 2013 when the 650 beat everything. It beat all the spacecraft. It beat everything out there. And they said that it was the greatest inventions of that year. And in 14, we got the Collier Award. So now I have the one on the far side in my house. Not really. It's in Smithsonian. But the other little one, we get to see it. It's at Gulfstream. So that's the third one of those that we have won. We talk a lot about longest range, faster at 9.0, advanced high-speed wing. Exactly what is that wing and how do we build it? When I couldn't send my presentation, so the guys were like, come on, you got to get it to us. I got to get it in here so that we don't have all of those problems that we just had, so that I knew everything would work. I couldn't do it. Gulfstream wouldn't release it. They wouldn't let me do a little sales pitch and, jumping in and rah-rah DDN, but they would let me do certain things. And so I didn't have a title on there, so the guys surprised me. The title is Getting to the Future Faster. What do we like, guys? We get you there. Get to the future faster because we get you there the longest ride and the fastest ride. That's the interior of the beautiful G650. It's kind of like my Delta flight over. It's exactly same pillows, 100% great air. Yeah, it was exactly like it. Okay, enough of the 650. It was our flagship. It's been out there for 5 years. Nothing competes against it. We believe it's at the top. We believe it's in a class unto itself. We don't believe anything from our competitors compete against it. We believe they compete with second and third ones of ours. But now, since Bombardier says they're coming out with another one, we don't like chasing people. So here comes the Gulfstream G700. Longest, biggest, most incredible, 10 windows on each side, the same size windows. Those suckers are about this wide and about this tall. You feel like you're outside. And I know I might take an extra minute or two, but I've got to show you this.
Please welcome President Gulfstream Aerospace Corporation.
This was 3 weeks ago. Can you hear it?
Good evening, everyone, and thank you for joining us tonight and sharing this moment with us. Through our employees' innovation, General Dynamics' continued investment in R&D, and the success of our past programs, we have been able to pull together the very best and most popular and innovative products and unite them into what we're going to see tonight. An aircraft truly worthy of the Gulfstream brand. Ladies and gentlemen, I would like to present to you the all-new G700.
In front of a crowd, we launched this marketing tool. And then I've got to show you the next piece of this because we actually launched 2 of the first G700s to show the world how far along we are. We rolled them out under their own engine power. Guys, I know I could talk all day long about how we set up supercomputing and what kind of Intel we use and what kind of GPUs we use and what kind of InfiniBand and blah, blah, blah. We can go through that, but this is why I'm here. This is supercomputing. Computing, it is competitive advantage. It is build the next one that's going to beat the competition. It is solve the science that no one else is solving. And my job right now is to make money for my company.
So the Gulfstream G700 brings together the best of 2 families of aircraft. It takes the innovation of the G500 and G600 symmetry flight deck and marries it together with the unmatched speed, performance, and comfort of the G650ER. And then pushes all that into the tallest, widest, longest cabin in all of business aviation. Gulfstream employees around the world working with our key suppliers have been hard at work designing, building, and testing the Gulfstream G700. Ladies and gentlemen, on behalf of the 18,000 Gulfstream employees worldwide, I'm honored to present to you the first of our new fleet of G700s.
This was the day before back in Savannah. And we wanted the world to know how far along we are because now we're competing against, sometime they're going to push out there. Look at that winglet. Amazing. On the run pad. How long that aircraft is. It's got 5 compartments. Full bed, full shower, seating for 8 at dinner, a 10-foot long cabin, cabinet space and countertop. And there's its little brother. Came in to show the world that we not only have one of them ready, we have 2 ready. So these will enter our flight test program along with, I think, 3 others. All right. Upper left corner, those advanced winglets, those 20 windows, longest, widest, tallest cabin, unmatched range, unmatched high speed, and data concentration network. So you guys can sum from that all of the CFD that we had to do, all of the new work that we needed to do on the supercomputer, and look at the data concentration network. This is an idea that over our next few years, we'll be taking data off of engines, off of avionics, off of any system that we put to the data concentration network. And then once we have that, think of the analytics that we can do, then the machine learning, and then the deep learning, and continuing to go. So we have a few systems rolling now, but I'm only starting. I'm going to get out of just a CFD business, along with some virtual and rendering and render farms and some of that other stuff. And we're going to get into some of the world that you guys get to play in, the hopefully all the way into the AI world. Largest, longest range. What's the title that I'm supposed to be working on? Getting to the future faster. I think this works. Thanks for the title, guys. All new, high-speed winglet. There it is. Blended, higher swept, aerodynamic efficiency. That will get us to the future faster. That was what I had, but if you guys have 2 more minutes for me, I want to show you a couple more things. Can I? All right, he's shaking his head yes. There's my one, and remember, if anybody asks, it was after the presentation, right? All right, so we have a front end. A front end before IME was coming around, we were having issues on the front end, and we decided to go with all flash straight up, and we went with Exascaler. So did I just hit a button again? So we went with Exascaler, and then that's a few hundred terabytes. That is just our fast scratch. We don't back it up. That's where they operate. That's exactly right. How long?
How long did it take you to take a decision to get DDN?
You and I met 4 or 5 years ago, and we've been talking ever since. And then we were looking when, let's see, we're filming this, aren't we? When we were using Panasys and looking at GPFS, and we used Luster for a long time. We've done a whole lot of things. We used Isilon for a lot of the stuff. So we kept lining it up to where everything was coming to an end, and I said, I'm getting close to end of life on some of the stuff. Let's move it. Let's change it out. And at that moment, we thought we were doing something new and that others weren't. We were like, I need fast scratch on the front end. And have you ever used Exascaler for this? And we're like, well, and we were starting to talk about IME, but we weren't quite there yet. And I'm like, screw it, buy it. So we threw that in on the front end, and now it is a fast calculator for these guys. And then when we're throwing it to project, we put it in long-term and short-term proj. We throw it over to GridScaler. So we're very familiar with all the different parallels, but you guys, thank you. You help us in our full parallel world. And then that's backed up by, a few minutes ago, we were talking about the data flow. That's backed up on that side through A-Tempo, and then it goes in tape to tape, and then we do all of our back-end stuff. So over my next few years, I'll probably step up into spinning disk and figure out the rest of my DR, but that's kind of where we are, and that was not part of the presentation. But this is. Because this is too cool. So the little guys, this is the 500 and 600 interior. This is the cabins of the 5 and 6. So they have about 7 windows down the side instead of 10. And yep, Paul's ordering right now. Go ahead, push the button. Oh wait, it's Alex. Alex is ordering. Who wouldn't want to do supercomputing for this kind of sexy beast? All right, let me quickly, here's the last little, I'll show you this one. I have to show you the new things we're getting to play in. We are building desktop flight simulators. We have all the CATIA data from the 650, 500, 600, everything after that. We use the CATIA data, keep it in 3D, and this is a desktop sim that me and my virtual reality guys did. This is visuals through the headset. So you're sitting inside the cockpit, you fly in and out of whatever airport, you can practice it. I stole a guy from the software and simulation group, and I tied him with my virtual reality guys. He now puts the control law inside the simulator, so we are actually flying very close to what the real one would be like. So it's got long legs. This is the cabin to where Fernando Toledo, he's been in this world for about 25 years. He built NIAR, he built Embraer, he built tons of these. This is our interior cabin, and this is the interaction that our customers do when they come in to buy. So we walk them into their aircraft long before the aircraft ever comes off the line. So they pick everything there, and see, we're out of here. Thank you all. Let's get to the future faster.
Do we have any questions in the room for Larry? So you said you didn't have you didn't have these huge resources. Can you give us an approximation in terms of what kind of computing nodes you're running and how much storage?
Yeah, it's a little squirrel spinning.
Yeah.
Well, let's see, the Intel guys, we are, let's see. What's one of the last ones about a year ago? Does anybody know? Intel chip, 30-something cores. Sky. I heard somebody say something. In about a year, we'll have nothing but. I have a lot of problem in my data center on cooling. We used, at the time that we were building it basically for the 650, no one knew what supercomputing was. Hell, like I said, I was a nuke. I'm now running this digital side of the world, and yeah, I'm a digital engineer, but I was trying to figure out, okay, what do these scientists need? So trying to marry those, and we went into a data center without water, about a 9-inch underfloor cooling. We've thrown in rear door chillers. We are doing everything with air. So back in the Intel Sandy days, Sandy Bridge was overheating, Ivy Bridge was overheating. We were baking them because I was using, at that time, a lot of blade technology. And so we were ramping up 50, 60 kilowatts a rack, and I was just frying them. So in about 2.5 years, they were all dying off. So we had to go back, and now we're running the 25, 30 kilowatt racks. But getting ready to, hopefully over the next couple of years, make some changes where I reintroduce water into the picture, hopefully, so that I can go past the Skylake and do some of the water-cooled chips. We've done a little bit of AMD in time. A long time ago we worked with IBM back in the iDataplex days. So yeah, we've had different ones, but now we're pretty much Intel shop. Most of our core codes are from NASA, so everything is set up to run on Intel. We are an InfiniBand shop, FDR. We haven't hit any blocking. I'll probably skip the next one and hit the 200 gig after that. And then on the back end, as I said, we'd already tried all the different brothers, and now we're with the DDN family.
Well, thanks so much.
Absolutely.